So let's first deal with putting these three guys together. Okay, how are they wired? Parallel. So how do we add up parallels? We use the, oh my gosh, the reciprocal equation. All right, so 1.575 ohm is what these three in parallel would be. So an easy way or a helpful way to do a problem like this is to redraw each step. Okay, so if I were to replace all three of those, I could redraw my circuit like this. So there would be the three in parallel I replaced with a 1.575 ohm resistor. And then there's the 6.3 that's still there, the 2.5 ohm that's still there, and the 1.5 ohm that's still there. Now, how is the new 1.575 ohm resistor wired with the 6.3 ohm resistor? They're in series. Okay, so then these are in series with each other. And how do you add resistors in series? You just add them up. So 1.575 plus 6.3, and I got 7.875. Now I can redraw the circuit again. So now I would replace these two with the 7.875 ohm resistor. This would be our 2.5 ohm resistor and our 1.5 ohm resistor. Now how are they wired? They're in parallel. And how do we add them in parallel? Use that reciprocal equation. So the reciprocal of the equivalent resistance is 1 over 1.5 plus 1 over 2.5 plus 1 over 7.875. And what did you get? Did you get that right there? .838 ohms. Alright, so this one, number 41, same circuit, 9-volt battery. So here's a battery. Boom, I'm going to put it in there. I'm going to do some color coding, so that'll be a 9-volt battery there. Okay, so the way a circuit works, the current leaves the positive side of the battery, and then it chooses a path to take throughout the circuit. So no, can't go into more than one path at a time. How is the 1.5 ohm resistor wired with the battery? This is multiple choice. Either it's series or it's parallel. Parallel because there's a choice. Anytime you can say or, the current goes here or there, then you know you have that's the beginning of a parallel. So how is the voltage, what's the rule for voltage in parallel? They're the same. So this is a 9-volt drop across the 1.5 ohm resistor. Alright, then what about the 2.5 ohm resistor? What's the voltage drop across it? Also 9 volts. So if I have the voltage and the resistance, we can find the current through each one of those. So we got 6 amps, 3.6 amps. Now, so the current leaves the battery. Some current leaves the battery, and 6 goes this way, and the rest goes this way. And then 3.6 amps goes that way. Now let's see. This, we already found the equivalent resistance of this circuit earlier. So we could just draw a little side note resistor over here, or circuit, where this is our 9-volt battery, and this is what, 0.838 ohms. So can we find the current that's running through the battery? Do we get 10.74? amps through the battery. So that's going to be this current right there. So how much current is left to enter this branch right here? Alright, so we've got that 1.14, what's left over, comes into this point. It splits up. I don't know exactly how it splits up, but then what's it going to do right here? Get back together, and so this will be 1.14 amps. So then what's the current through the 6.3 ohm resistor? Yeah. So can you find the voltage across the 6.3 ohm resistor? Alright, so we got a 7.2 volt drop there.